Welcome to the first module in the LAN Troubleshooting Essentials course. In this module, we're going to be talking about troubleshooting philosophy and methodology. The troubleshooting philosophy that you hold will drive not only how you deal with problems when they occur, but how you address problems that maybe they've not even occurred yet. So a troubleshooting philosophy says, do I wait to troubleshoot until there's a problem? Or am I continually monitoring to attempt to prevent problems? And then a methodology is the process I use when I actually have to troubleshoot. Let's start then by talking about the philosophy. So which approach do you employ? Interrupt-driven or structured? Now the reality is we have to do both. We will always have interrupt-driven troubleshooting philosophies. The concept is that if there's a problem, we've got to fix it, even if we do normally implement a structured model. So interrupt-driven says I'm going to fix the things when they break or when users complain enough. So when there's a problem, I deal with it. Structured says I'm going to constantly create network baselines and compare them with monitoring and analysis on a weekly basis, a monthly basis. I can see trends in this way. And based on these trends, I can do planning, and then I can also implement ongoing maintenance. Another thing to think about is that we have metrics that we can use, like mean time between failure, to determine when a device or a component is likely to fail. If I know it's very likely to fail after being used for 4 years, then I may want to consider some special analysis or testing of that equipment at the 4-year mark. And then at the 5-year mark or later, I may want to just replace it proactively. Now, this is not something every organization can budget for, but it's something to consider in relation to the structured approach. By replacing hardware before it fails, you prevent an interrupt-driven problem. Let's be real though, I can implement a brand new switch or router tomorrow, and it can fail the next day. The hardware can literally fail the next day. So while the mean time between failure is a great statistic, it's just an expectation. It's an average. It is not necessarily what every device is going to do. Some devices may last 12 years, others may last 12 minutes. So obviously we'll have some initial burn-in testing. If they work for an hour or two, then more often than not, they're going to be stable for years to come. But it is still possible they could fail. Therefore, this is why I say we can implement a structured philosophy, but we also have to be prepared to address interrupt-driven problems whenever they occur. For those interrupt-driven problems, we can use methodologies. And the first set of methodologies I want to talk to you about, 3 of them in fact, are OSI model troubleshooting methods. Now you may be familiar with the OSI model. The OSI model is a 7-layer model: the physical, data link, network, transport, session, presentation, and application layers, being layers 1 through 7. This model is not something I want to explain in detail here. I assume you know that from some of our other courses or from other educational materials that you've reviewed. The goal here is to talk about how this model can be used in the troubleshooting process. So for example, keep in mind that the physical layer would be your cabling and your switch ports and your network adapter cards. And the data link layer would be, of course, your MAC layer. When we're talking about Ethernet, we're talking about MAC addresses and the devices communicating with those MAC addresses, and the same is true for wireless LANs. When we're dealing with the network layer, we're dealing with IP, IPv4, IPv6, and possibly other protocols as well. The transport layer is where we deal with TCP and UDP. The session layer through the application layer, we often group together and say this is where we're dealing with the specific kind of application and data structures or formats that we're utilizing. So as a troubleshooter, I can say, well, I want to do bottom-up troubleshooting. So I'm going to start at the physical layer and troubleshoot my way up to the application layer. Alternatively, I could say I want to do top-down troubleshooting. I start at the application layer and I work my way down to the physical layer. And of course, alternatively, I can actually say I want to do inner-out troubleshooting, where I start on the inside and work my way out. This is also called divide and conquer, because you're dividing somewhere along the OSI model, and then you're conquering your way up and down. Now, how do I know which of these to use? Well, here's a simple thing you can look at. Not every scenario is this simple, But when you have one computer having a problem, and only that computer is having a problem, and no other computer on the network is having a problem accessing a resource or something, then you'll tend to start with the physical layer. Particularly, this is true if they say, I can't do anything on the network. If, however, you have many different devices that are experiencing problems, you'll either start with the physical layer on the service that they're trying to access, or you'll go with the top-down approach. Okay, is this the only application that's having a problem? Or is this the only transport layer protocol or network layer protocol having a problem, and so forth? And then in or out is kind of that experiential-based method. So you have experience with it, and you know that it's very likely an IP problem, a network layer problem. So you decide to start there. And if you rule that out, then you can either move up or down as should apply. So these are OSI methods that can be used in the troubleshooting process. Another method we have is the follow the path method. And this is looking at the network more as an entire system, a collection of devices that all work together to form this network. The follow the path method says, all right, if my local stack, my 7 layers of the OSI model, seems to be fine on a switch or a router or a device, an end device, for example, then what I want to do is ask, well, how far is my communication getting before it stops working? Where in the path is the problem? Is it at the other end, or is it somewhere in between? So the follow the path method says we're going to look at the different devices along the path in order to see if they're operational at the different layers that they need to be, and if I can pass through them to the next step in the path. Another method that we can use is the what's changed or what's different method. The what changed or what's different method says we want to know if there's anything different on this device that's not working today, particularly if it was working yesterday. This is also sometimes called spot the difference or compare configurations. So let's say I have 17 laptops of the exact same model used for the exact same purposes, and one of them is having a problem, but the other 16 are working just fine, and they're all on the same network. Well, then I might look at that one device and ask, what's different? What's changed? Have there been configuration changes recently? I can compare the configuration against my base configuration that's supposed to be on that laptop to see if there's anything different. This is the what changed or what's different method. Finally, I'll share one more. We have the move it method. The move it method is the method that goes all the way back to the earliest days of computers with all of the different components that are in a computer. It's also known as swap components or move the problem. So the move it method says I can swap out a component. I might swap out a network interface card, a NIC, to see if that resolves the issue. I might move the Ethernet cable to a different switch port and make sure that port is configured appropriately and see if that resolves the issue. I may move the problem. So I might take the device and go to a different network segment. I might not have to physically move the device. I might just be able to move the cable to a different segment or change the switch port to a different VLAN, something like that, in order to move the problem and see if the problem is resolved. This can help me to identify things like VLAN misconfigurations or switch port failures and so forth. So these are all different methods or methodologies that can be used in the troubleshooting process in both philosophies, both the philosophy of waiting until it breaks, interrupt driven, and the proactive methodology, which is a structured philosophy for troubleshooting.